Welcome to Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. I am here with poison ivy. So if I look a bit blotchy, you know why. Before I jump into the science news, I want to take a moment to remind you that this show is funded through the combined generosity of our Patreon community and the individual donations of people like you. In the month of May, we are making a special push to grow our community, which basically means we're doing one of the things we hate most, a pledge drive. Would you please consider supporting CosmoQuest and all our educational content, including this show, at patreon.com/CosmoQuestX. And now, to talk joyful science. This week, I refuse to talk about the U.S. science cuts or climate change or anything else that I don't find joy in. We are only going to talk about happy or at least neutral science. For instance, the Sphere X mission is now collecting survey data. The Rubin Observatory may not be collecting survey data, but it is collecting commissioning data. And these are amazing things. Astronaut Don Pettit has now been back to Earth long enough that he's starting to release processed images from his time on the International Space Station. These too are amazing. And, as we're going to discuss in our closer look, there just might be a planet in the outer solar system that isn't the Planet 9 we were looking for. We're also going to talk about alien solar systems that are sufficiently weird that some folks are claiming they have aliens, although there probably aren't aliens. And if that wasn't enough weird science for you, JWST has caught images of Aurorae on both Jupiter and, for the first time ever, Neptune. All this and more is coming to you right here, right now, on EVSN, a product of CosmoQuest, and supported through our Patreon by you. We hope by you. Go pledge if you haven't. A year ago this week, on May 10th through 13th, 2024, the sun triggered an amazing series of aurorae that were visible to folks living in the mid-latitudes, folks like me. Those amazing few nights and another set of events in October 2024 reminded all of us that our sun is a wild and crazy star, capable of turning the darkest nights into a technicolor dreamscape. Data from the National Oceanic and Atmospheric Administration, or NOAA, indicates that the number of sunspots on our sun's surface may be on the decline. And as we start the slow slide down towards solar minimum, the likelihood of more such storms will decline for the next 6 to 7 years. I still think this coming fall will offer sky watchers in the extreme north and south the chance to see a remarkable show. But for the rest of us, the season of aurorae is likely over. Earth isn't the only world that has aurora. In the past, all the worlds with strong magnetic fields have put on some sort of an auroral display. From Mercury's X-ray aurora that were spotted most recently by Bepi Colombo, to Jupiter, Saturn, and Uranus's polar light shows that appear in many different colors, including infrared and ultraviolet, world after world has channeled electrons from the sun through their magnetic fields and generated light. Now, for the first time, JWST's powerful gaze has unambiguously captured light from Aurora in the atmosphere of Neptune. back in 1989, the Voyager 2 mission caught data that wasn't quite good enough to say, yes, we definitely saw Aurora. The cameras on Voyager just weren't sensitive enough to the right colors. Now, 35 some odd years later, the JWST has partnered up with our overactive sun to get definitive images. JWST and HST both looked at Neptune in June 2023. In JWST's infrared images, light from ionized hydrogen molecules were caught. This particular ion is created in Aurora, where the sun's particles knock an electron out of trihydrogen. Aurora at Neptune look different than Aurora on any other worlds because Neptune has a weirdly tilted magnetic field. For unknown reasons, its magnetic field sticks out at a 45-degree angle, which causes its aurora to extend around mid-latitudes like a weirdly patchy fog. This is one of those particularly beautiful oddities of our solar system. Here's to hoping that HST and JWST are able to team up to continue capturing these kinds of images for many years to come. Neptune isn't the only world that JWST has explored for Aurorae. In December 2023, JWST observed ionized hydrogen molecules in the atmosphere of Jupiter. This massive gas giant's magnetic field is well aligned with its rotation, and the glowing gas appears as a crown on Jupiter's northern pole. What's particularly cool is that Jupiter's aurorae is bright enough that JWST can take short exposures and see how the aurora evolves over time from half a solar system away. Not a week goes by without JWST finding something new and pressworthy. Given the cost of this telescope, this is as it should be. And weirdly, at least some of the things it's found are not aliens, despite people's best attempts to say they are aliens. Case in point, JWST discovered that the planet K2-18b has the molecule dimethyl sulfide in its atmosphere. This is a Haitian world with a massive liquid water ocean and hydrogen-rich atmosphere. It would be amazing if this pretty common kind of planet can support life. And dimethyl sulfide made a lot of people think maybe this could be a hint in that direction. Here on Earth, this molecule is produced by phytoplankton in the oceans, bacteria in sewers, and it is a source of the stink of rotting meat. These are all biological sources, and some really hopeful people are really hoping that the dimethyl sulfide in K2-18b's atmosphere is also from a biological source. But here's the thing. The comet 67P also had dimethyl sulfide, and some interstellar clouds, including ones in the galactic center, also have dimethyl sulfide. We don't know for certain how it got any of those locations, but non-biological formation mechanisms are the most likely answer. So sure, K2-18b has a molecule that life can create, but it doesn't have to be formed by life. So, is it aliens? I'm gonna go, no, man, not this time. Extraordinary claims require extraordinary evidence, and one stinky molecule does not extraordinary evidence make. There are a lot of really solid scientists putting a lot of thought and observational time toward looking for life orbiting other stars. From searching for biosignatures in atmospheres to looking for technosignatures like radio signals or laser pulses, researchers are looking in a variety of different ways. While this hasn't found us definitive evidence of alien life, it has found some weird things, including most recently some super high-speed pulses in the light of sun-like stars. Retired JPL astronomer Richard Staunton has been using a 30-centimeter telescope at Big Bear Observatory to look for optical signals of alien life. On 3 different data sets, he detected pairs of pulses that lasted just fractions of a second and were a few seconds apart in time. Since a massive star can't change in brightness as fast as these pulses change, the source has to be something else, either an interloping source or some kind of optical shenanigans. In a truly delightful paper in Acta Astronautica, he compares 2 of these sets of pulses to a variety of things known to mess with observers, including planes, satellites, meteors, and even birds. Yes, folks, he includes a plot of starlight over time for a star being observed while big ol' bird flies in front of the telescope. Since he was out looking for signs of alien life, it is an easy jump for people to say, well, couldn't these pulses be that sign? As always, and as I shall repeat as often as needed, extraordinary claims require extraordinary evidence. In this case, good old physics can explain what is seen, mostly. When light is blocked by the edge of an object, the wave nature of light can cause a brief brightening prior to darkening. Easy peasy. At least sort of. While this is a good match, what was seen would require 2 events to create 2 blips. And that implies there is some sort of a ring hanging out somewhere in our solar system periodically blocking light. Or alternatively, this is me reading graphs, a pair of objects that are really close in size, flying around, blocking light one after another. That is also super weird. As Staunton points out, quote, if anything like this were found, it would immediately raise the questions of where it came from and how it could survive millions of years of collisions with other objects. Whatever is found, those speculating that our best chance of finding evidence of extraterrestrial intelligence lies within our own solar system might have much to ponder. End quote. After a break, we'll be back with an in-depth look at the outer solar system's possible hiding planets. Stay tuned. There are days when it seems that our outer solar system has the singular goal of frustrating astronomers. In a way, we have no one to blame but Newton. After all, his equations of motion allowed researchers to realize that Uranus's motion required something to be pushing and pulling on that planet. William Herschel found Uranus in March 1781, and for the next several decades, he and other observers carefully watched its slow motion through the stars. By 1845, it had completed an orbit that could only be explained by the presence of another large planet in the outer solar system. Mathematicians Urbain-Jean-Joseph Leverrier in Paris and John Couch Adams in Cambridge, England, made their calculations, and in September 1846, astronomer Johann Gottfried Galle found Newton within a degree of where Leverrier predicted. Neptune's also somewhat wonky orbit also led folks to go searching for yet another planet. And ultimately, Clyde Tombaugh found Pluto, an object much, much smaller than what anyone expected. We now know that Pluto is not responsible for Neptune's out-of-round orbit, and in fact, no large world is required to explain its elliptical orbit around the Sun. And in 2006, astronomer Michael Brown killed off Pluto's planetary status with the discovery of another similarly sized icy object out in orbits near Neptune and beyond. Pluto, by the way, was not the first planet to get demoted. That title goes to Ceres, the largest of the asteroids. Like Pluto, it was the first object discovered in what would turn out to be a belt of objects. Today, we call Ceres the largest object in the asteroid belt, and Pluto one of the largest objects in the Kuiper belt. And we argue over the definition of planet. As I said, the outer solar system has a goal of frustrating astronomers. As we found more and more objects in the Kuiper belt, it was expected that they'd map out a random set of orbits much like the asteroid belt's objects do, with things oriented every which way as they spiral around the sun. Weirdly, that isn't the case. And trying to understand why there is a freakishly large number of orbits weirdly oriented in vaguely one direction has become what sometimes feels like a combat sport. The opening round of shots fired came from Michael Brown and Konstantin Batygin, who called for a new search for a Planet 9 capable of gravitationally tweaking minor planet after minor planet into vaguely aligned orbits. They made predictions for its orbit, then they started searching. And it hasn't been found. It's entirely possible that it is out there doing its best to reflect as little light back at us as possible. A low albedo, not very reflective object could easily be hiding from all our existing data sets. We are, after all, looking for something that is significantly further out than Neptune, like potentially 20 times further out than Neptune. And at that distance, it would both receive a lot less sunlight, and its light would have to travel a whole lot further to reach us. The combined effect is an object that would be hundreds to thousands of times fainter than Neptune. But what is a factor of 1,000 among friends? It is understood that Rubin Observatory will be able to see Planet 9 if it is out there. Within a couple of years, we will either have found it or we will know something else is very weird about our solar system. But no one wants to wait. And astronomers have started getting super creative in how they are using archival data to look for potential new worlds. In general, planets give off most of their light in the infrared as they shine warmly. This means our best bet for finding Planet 9 is to look for moving dots in infrared sky surveys. Not many such surveys exist, and none of them lasted long enough to be able to readily see the kind of super slow motions we'd expect from an object far beyond Neptune. That said, 2 surveys were similar enough and spaced out enough in time to compare their data. These surveys are the Infrared Astronomical Satellite Survey, or the IRAS survey, which did science from February to November 1983, and the Japanese Akari Infrared Satellite, which surveyed the sky from February 2006 to August 2007 in far and mid-infrared. The 26-year gap between these 2 surveys means that together they should be able to catch the motion neither can see alone. Over the course of 1 generation, we expect a distant planet to move not quite a degree across the sky. Put another way, such a world would travel less than twice the moon's diameter across the sky. Using software, researchers led by Terry Long Fan looked for objects that appeared in one survey but not the other, and that appeared within a degree of an object that only appeared in the opposite survey, and that appeared about the same brightness in both surveys. This is a much harder software problem than it sounds like. The 2 surveys are very different, and a lot of calculations have to be done to figure out what it means for 2 points to have the same brightness in the 2 different surveys. But it's still just math, and computers can do this for us. A whole lot of software writing and waiting for the software to run later, the team found exactly 1 pair that fits the bill. And that 1 pair, if it is real, is nowhere near where Planet 9 is supposed to be. In fact, if this is a real planet, then the planet 9 Brown and Batagen predicted probably isn't out there, because its orbit would interfere with this new possible object's orbit. But here's the thing. All they have are 2 data points of light. In the Akari data, which looked at the same spot 6 months apart, the point only appears in one image, which means it either is an object moving as expected, or it is something that changed in brightness. All sorts of stars vary in brightness for different reasons. It's entirely possible that 2 stars just happen to vary in brightness between the 2 surveys. It's also possible one of these points is a false detection, or there are a lot of things possible that aren't planets. But the 2 points they observed are enough to predict, somewhat vaguely, where on the sky that possible object just might be today. And with a night or 2 of telescope time, they should be able to go looking for this object using existing ground-based telescopes. If they can get a good enough position with something like the dark energy camera, they can then follow up with the JWST or another massive scope capable of taking spectra and verify if we are looking at a new planet or something entirely different. This work appears in a preprint posted on archive.org that is being discussed everywhere from the journal Science to the Bad Astronomy blog on Hive. In the paper, they make it very clear that they need time with the dark energy camera on the Blanco 4-meter telescope at Cerro Tololo in Chile. If this were me, I'd be leveraging this paper to try and get directors' discretionary time to go hunting for this planet. I don't know where in the sky their object is located, so this hunt may require waiting for the object to be well placed in the sky. But if we're lucky, there could be a follow-up paper in the coming months letting us know a new object has, or has not, been found. I'll be following the story as closely as I can. When I know more, I'll bring it to you right here on EVSN. After another break, we'll be back with this week's Tales from the Launchpad. This week, our producer is actually filling in as an aerospace correspondent using notes from Eric Mattis, who is busy moving. So I am pleased to welcome on Ali Pelphrey for this week's Tales from the Launchpad.
Hi Pamela, it's Chinese launches and Starlinks all the way down this week. Let's get into it. On May 11th, China launched 3 Yaogan satellites from Launch Complex 9 at Taiyuan Satellite Launch Center on a Long March 6A rocket. The satellites are officially described as, quote, electromagnetic environment probing, but they are generally thought to be low Earth orbit recon satellites for the Chinese government. On May 12th, China launched Communications Technology Test Satellite 19, also known as TJSW-19, from Launch Complex 3 at Xichang Satellite Launch Center on a Long March 3C rocket. Official sources suggest that TJSW-19 is a more modern, high-throughput communication satellite operating exclusively on behalf of the Chinese government and/or military. On May 13th, China launched a space computing constellation from Launch Area 4 at Jiuquan Satellite Launch Center on a Long March 2D rocket. Per space launch schedule, the 12-satellite constellation will test in-orbit data processing capabilities for other satellites with artificial intelligence assistance, as well as inter-satellite laser link communications techniques. Since our last recording, there have been 220 Starlink satellites launched on Falcon 9 rockets. We keep track of orbital launches by launch site, also called spaceport. According to rocketlaunch.live, so far this year, the USA has had 65 launches, China 27 launches, New Zealand 5, Russia 3, French Guiana 2, Kazakhstan 2, India 1, Japan 1, and Norway 1. Of these 107 launches, there have been 5 failures, reminding us that space is hard. Also, there are currently 9 toilets in space.
Thanks, Sally. Before we go, one weird bit of news and a couple of announcements. First, the science. Showing that alchemy is possible if you have a big enough particle accelerator. Researchers using the Large Hadron Collider have managed, not entirely on purpose, to transform lead into gold. According to a press release from CERN, quote, near-miss collisions between the high-energy lead nuclei at the Large Hadron Collider generate intense electromagnetic fields that can knock out protons and transform lead into fleeting quantities of gold nuclei, end quote. And when they say fleeting quantities, their paper states they estimated a total of some 2.9 times 10 to the negative 11 grams of various gold isotopes were produced. That is still about 100 billion atoms. But given the cost of running the LHC, no one's going to be getting rich. And that is all the science for now. Before we go, I wanted to let you know that we're going to take off the rest of the month of May. Eric is settling into a new apartment and needs to settle into his new city life. Allie is going to be out of commission with some health stuff, and I'm going to be launching new citizen science projects and expect to be chasing bugs as we get the new system online. We will all be back in June. And as you plan your summer and fall, I'd like to invite you to join me on a trip to Lassen National Park in September. I'm going to be leading a science excursion with Galactic Medallion Travel, along with my colleagues Kirby Runyon and Mark Wagner. Information on how to sign up is in the show notes for this episode. We'll see you in a few weeks online, and maybe see you in person in the fall. Good night, everyone, and remember, go out and look up. Oh, and please give this video a like and subscribe so the algorithm tells you and the world when new science is ready to be learned.